Hello there. We are going to talk about factoring again today, and specifically factoring when we have a coefficient in front of the x squared. So we actually have an a value. We have an x in the form ax squared plus bx equals, plus c. All right. So that's our learning target to factor trinomials in the form ax squared plus bx plus c. We've already learned um, kind of the reverse FOIL method, looking for target numbers for just x squared plus bx squared, bx plus c. All right. So the purpose of factoring is to get rid of the squared values and break the problem down into their smaller parts. So kind of like we're just factoring in general. We're going to talk about three different methods today to learn to factor these types of trinomials. I'm going to teach you all three. My suggestion is to pay attention to all three and really focus on the last one, the third one. I think the third one is the best. I think that's the one that'll make sense and it'll work the most. But certainly pay attention to the other ones as well. So method one. All right. Here's what we're going to do. It's called the guess and check method. Again, guess and check, it can work at times, but it's not the best method. This is going to take us a while sometimes to guess the right things. So here's what we're going to do. Make sure the terms are in descending order, meaning ax squared. The x squared is in front, then the x term, then the constant term. All right, that should already be there. Factor out the greatest common factor if there is one. Okay, if you can factor one thing out of all of them, do that right away. All right, multiply the coefficient of the first and the third terms together, the a and the c, because those are going to be help us find our target numbers. So finding target numbers, find two numbers that multiply to give you that product that we just did, and add to get the coefficient of the middle term. Still the same way as we did before, but it's going to be a little bit more challenging because now we have an a value. All right, set up the parentheses. The first term in the parentheses will be multiplied together. So if you FOIL it out, it should be the first part of the FOIL. So we have to determine what you need to do, put in those two locations, the first parts, so that this will actually work with the target numbers. In essence, you're splitting up this term into two to put it in the parentheses. If the coefficient of the first term is something other than 1, you will almost always use factors other than 1 for that number. All right? You'll need to make sure that when multiplying the outsides and the insides together, you find the correct values. And finally, after completing both parentheses, always check by foiling. So, didn't give us any specific things here. We're just looking for numbers. So here's an example. We have 4a squared plus 4a minus 63. So if you multiply a and c together, you get negative 252 right here. So we wanted to multiply to get to negative 252 and add to equal 4. So that's going to be challenging because if you look right here, we have a ton of possibilities. Negative 1 times 252, 1 times negative 252, all the way down, and we don't figure out the one that actually works until we get to negative 14 and 18. Lots of different options, and that'll take you a while, a lot of playing around, and a lot of guessing and checking, which is why this takes a long time, but it can work. Okay, so now that we've done that, oops. Our target numbers, we have negative 14a and 18a. So split the f term into the first parts of each. So we have, so our first one we have 4a squared. It has to be split up. So we're going to do 2a and 2a. Hopefully this will work out. All right, multiply 2a by something on the outside to get either negative 14 or 18a. So if we multiply it by negative 7, that'll get us 14a. Multiply 2a by something else, so then we get multiply by 9 to get 18a. Let me get rid of this and go back to this. Okay, so we've got 9 and negative 7 will get us to those two target numbers if we have two a's in the 2a in the front. And so then we have our two binomials, 2a plus 9 and 2a minus 7. It should work out. Now if we were to FOIL it, we would end up getting our original 4a squared plus 4a plus negative 63. Okay, again, there's a lot of guessing and checking, and there's that many different factors that could work for target numbers. So why don't you try it using your guessing and checking method here. We've got 6x squared plus 23x plus 7. So I'm going to pause right now. Why don't you pause it and just try it. Give yourself a try of it. If you're really struggling with it, you can unpause it and follow along. All right, so I figured out that our target numbers have to be multiplied equal 42 and add equal 23. So the ones that I found were 21 and 2. So let's set up our parentheses. And I'm just going to try 3x and 2x in front. It could potentially be 6x and 1x because those also multiply to equal 6x squared. I'm going to try 3 and 2. See if there's if we can multiply numbers to get to 7 here. So if I do 2, so I think it's going to have to be 7 and 1. So let's try plus 1 and plus 7. If I foiled that out, I'd have 14 for the insides, and I have 3x. That would not be 23x, so that's not going to work. So let's flip it around. Let's do 1 and 7. Let's try plus 1, plus 7. That would, if our insides would be 2x and the outsides would be 21x, so that will get us our 23x in the middle, and then the outsides and the fronts will work as well. So when you do foil this, you get 3x, you get 6x squared plus outsides would be 21x, insides would be 2x, and then last would be 7, and that'll give us 6x squared plus 23x plus 7. Okay? Again, a lot of guessing and checking. It doesn't work perfectly, but it's very similar to the method that we've done, only now we have to figure out also those front numbers because we're going to have something other than x. All right, let's try method number 2. Method number 2 it's typically called the distributive property. I think I've heard it also called as the break apart method. Here's what we're going to do. I'll break down the steps for you, and then we'll put it into action, and we'll see how you do with it. So this is another valuable method to know how to do. So if you make sure the terms are in descending order, factor out the greatest common factor if there is one. So that's the same 2 steps. Multiply those first 2 numbers to help you find the target numbers, okay? They have to multiply to equal those first 2 numbers and add equals b. All right, so now we're going to rewrite the original problem, but replace the middle term with our 2 target numbers. So we're going to rewrite the polynomial. And now we're going to break it into 2 smaller problems so that you can factor out a greatest common factor from each pair of terms. Okay? And this is going to be kind of like reversing the distributive property. Okay? So put the greatest common factors of each term into one parentheses and the common binomial into the other parentheses. You have to have a common binomial. So here's how it works. Here's what that all means. We've got this example. We've got 5x squared plus 11x plus 2. So if we do the multiply to equal 10 and add to equal 11, well, that actually will work out really easily. 10 times 1. So we're going to break this middle part apart into 2 parts. 10x and 1x, because that'll be the same as 11x. So now we have actually 4 parts to our polynomial. We have 5x squared. That didn't change. Now it's plus 10x plus 1x plus 2. I don't know that it always needs to be I think it should be in descending order, so 10x should come first and then 1x. It might not always work that way, but we'll see. All right, now split the 2 problems. So we've got 2 parts. We've got 5x squared. We broke it up into this part plus this part. Okay, we want to pull out a greatest common factor now. So in this front one, we can pull out 5x for most, and then we're just left with x plus 2 on the inside. So now if we distribute it, it's like the distributive property backwards. So if we distributed it, we'd get back to that 5x squared plus 10x. The only thing we can pull out of this back one would be 1, so let's put the 1 right there. All right, we pulled out the greatest common factor of each. All right, now we're going to break it apart, and we're going to put it 2 parentheses. The 5x plus 1 is going to be in 1 parentheses, and then our common factor we're going to have there as our other one. So it would be the common binomial that's left. And there we go. There is our 2 binomials that factored out using this just kind of reverse distributive property or this break apart method. If you were to FOIL it now, it would work out. We'd get 5x squared plus 10x plus 1x plus 2, which would be plus 11x plus 2. Okay? So either follow along or pause it and try this on your own. All right? So here's what we're going to do. We're going to find it's got to multiply to equal 30, add to equal 13. So I think that's going to be 10 times 3. That'll work. Okay. So we're going to break this up into 10 times 3. So this time we're actually going to put 6x squared. I'm going to put the 3 next. So I can already see 3x, that the 3 and the 6 are going to go together, and the 10 and the 5 are going to go together. So this is where it's not actually in descending order for that one. Now if we break it apart, we've got this plus this. I'm going to pull out a greatest common factor. So I can pull out a 3x from both the front, or both of the ones in the first one. And I'm left with, so that would be, oops, 2x. Yep, that would be right. And then just 1. X times 1 would get us to the 3x. All right, second one, we can pull out a 5 from both. And we're left with, hopefully we're left with the same common binomial, which would be 2x plus 1. We are. All right, now we can break it apart. We've got a 3x plus 5. That's the one, the outside. And then the common binomial is 2x plus 1. And there we go. So this distributive property, this break apart method, again, is great if you like it, if it works out for you. It'll work every time. I actually really like this one. Okay, so if you were to FOIL it, then you should get back 6x squared, 3x plus 10x, we get 13x, and then the last would be plus 5. So there we go. That's factoring it using this method. All right, the third method is called the bottoms up method. So again, I would say now, this is my favorite, but I actually really like that distributed property one. Pick one of them. All right, don't try to do both. Pick one of them. Here's the method. Put the terms in descending order and factor out a greatest common factor if there is one. All right, multiply the a and c together because that'll help us find our target numbers that would also add to equal to b. And set up the parentheses. Here's how we're going to set it up. Oops. We're going to set it up so it's x plus whatever the one target number is times x plus whatever the other target number is. And we're actually going to put the coefficient of the first term under each target number. So, well, we'll see that. If you had the a value was 6, we put the 6 under those two target numbers. So it actually make fractions. If the fraction reduces to an integer, replace the fraction with that integer. If the fraction does not, move the denominator to the front of the variable. And actually reduce it either way as far as it can, but if it doesn't reduce to a integer, we want to pull that in front and make that the coefficient of the x. So let's do that together here. So you have 3x squared plus 10x plus 8. So again, multiply to equal 24. We're finding the target numbers again. That's 24, and add to equal 10. I think it's going to be 6 and 4. Yep. All right. So with those 6 and 4, we're going to do x plus 6 times x plus 4. But we're going to take that coefficient, which is 3, and we're going to put it, this is that next step, put it underneath the 6 and the 4, underneath the target number. So we have actually x plus 6 over 3 and x plus 4 over 3. And reduce if we can. 4/3 does not reduce, so we're going to pull that 3 and put it in front of the x. 6 over 3 does reduce, so that's just going to be a 2. So we have x plus 2 and 3x plus 4. It's called the bottoms up method because since there was something stuck on the bottom here, we brought it up and put it in front of the x. And there we go. There's our two binomials. You can double check it. It'll work. The FOIL method, we get 3x squared and 6x, and then 4x. That makes our 10x. And then the last we get s plus 8. That's the bottoms up method. Again, I think this is the easiest one. Definitely one of the last two methods are the easiest one, but why don't you try this? So looking at those steps, try this using those steps on your own right now. If you'd like to pause it, if you really don't have a clue, you can just go along with it, but make sure you're going through it and you understand it. All right, target numbers. Multiply to equal -14, add to equal -13. So it's going to be -14 times 1. All right, so I'm going to set it up x minus 14 and x plus 1. Those are our two target numbers. We have to take that coefficient of 2 and put it underneath. Can we reduce either of them? Yes, we can. We could reduce this to x minus 7. This one we cannot, so we're going to do bottoms up. We're going to bring it up in front of that x. So we have 2x plus 1 now is our other binomial. And we're done. Very quickly, we are done. If you wanted to FOIL it out, it'll get you that same result, which is super awesome. That's why I like this one so much. I don't know. It's a weird method, but it works every time. So that is the bottoms up method. Okay? So three methods, I would suggest one of the last two, the bottoms up or the distributed method. But make sure you know one of them. And my closing question, my closing thought for you here is just to compare and contrast factoring. We did a bunch of factoring to putting together a puzzle. How are those two similar? How are they different? So think about that one as you think about your goal for today, which is to factor trinomials of the form ax squared plus bx plus c. Have a great day, everyone.